Hi, my name is Timothy Vallier, and I'd like to welcome you to the processing portion of Introduction to Computational Arts. Processing is a free and open source programming language and IDE, or integrated development environment. In this section, you'll learn the basics of computer programming and implement them in a visual context, allowing you to visualize, design, and create generative art. We'll begin with an introduction to computers and file systems, including detailed instructions on how to install processing and external libraries. I'll teach the basic principles of creating and processing, including colors and shapes, typesetting and images, and working with dynamic structures. After the first 3 weeks, I'll see you again at the conclusion of the course to go over publishing your work on the web. And so, let's get started working with processing. There are no prerequisites to start creating with processing, but there are a few things you should be familiar with before we dive in. First is a familiarity with the basics of computing. In this presentation, I'll be covering the following elements: computer organization, operating systems, the boot process, data types, and personal computer hardware. Familiarity with these elements is essential to grasping the power and potential of processing. The elements of a computer that I'll be defining include the computer itself, a program or programs, physical hardware, and software. The most basic question we must first answer is, what is a computer? To keep it simple, a computer is something that performs computations and makes logical decisions. Next is a program. A program is a set of instructions by which a computer processes data. Therefore, programming is the process of writing the instructions for the computer. Hardware includes the physical components and devices that make up the computer system, and software is the collection of programs bundled as packages to be executed by the user. A computer is organized into several units, accommodating input and output mechanisms. An input unit is an external piece of hardware allowing the computer user to send discrete commands to the computer. Two examples of this include the keyboard and mouse. Both of these devices provide direct input into the computer. In order to create a feedback loop with the computer, we must have output units as well. These items, including the monitor or display, a set of speakers or headphones, and sometimes a printer, allow the computer to output the results of the user's input in both visual and auditory terms. In order for the computer to keep track of the input, a memory unit is required to store process information. The memory unit allows for speedy data storage and retrieval, but information is only stored in memory temporarily and will not remain on the computer long term. The ALU and CPU, or Arithmetic and Logic Unit and Central Processing Unit, are the units which perform calculations. The ALU performs arithmetic and logic operations, while the CPU supervises the operation of all devices. Lastly, in order to store programs, software, and other data for the long term, a computer requires a secondary storage unit. Secondary storage units typically appear as hard disk drives and are capable of storing data that will remain until it is removed or overwritten. The process by which a machine goes from a resting state, powered off, to a usable state, powered on and ready for input, is called the boot process. Each computer goes through a similar sequence before it becomes operational. The first step is to provide power to the machine. This is usually done by triggering the on-off switch on the computer. This provides power to all components, including the CPU, which first runs the BIOS, or Basic Input-Output System of the machine. This then loads the boot sector program. The boot sector program allows the computer to access the secondary storage unit and trigger the loading of the operating system files into the computer memory. Once this process is completed, the operating system configures the various hardware to prepare for input and output. At this point, the computer is booted up and is ready for the user to issue commands. Now, you'll take a brief quiz on what we've covered so far. When discussing the boot process, I concluded with the loading of the operating system. An operating system is a collection of software created to help manage the computer hardware resources and provide common services for computer programs. In this class, the operating system consists of either Windows or Mac OS X. It serves as the platform and graphical user interface for us to create processing sketches. Modern operating systems allow for multi-programming, which is the combination of multitasking and multiprocessing. Multitasking is the fast switching between running programs, allowing the computer to run several pieces of software simultaneously. Multiprocessing involves computers containing multiple CPUs and distributes work across the various CPUs. While discussing memory and hard disk drives, I introduced data storage and retrieval, but I did not cover the types of data that computers handle. For the purpose of this course, I'll be discussing the following data types: machine data types, Boolean data types, numeric data types, and composite data types. Machine data types are the most basic data types, stored in bits of 1 character length and indicating either a 0 or 1. This is the smallest addressable unit of data on a computer. Bits are organized into groups of 8, which form a byte. These continue to stack into familiar-sounding groupings of kilobytes, megabytes, gigabytes, terabytes, etc. Boolean data types are values which indicate a true or false state to the machine, and are typically communicated as 1 for true and 0 for false. Numeric data types are used to express numbers and include integers, whole numbers such as 3, and floating point numbers or numbers containing fractional values such as 3.58. Lastly, we'll be dealing with composite data types, including an array, allowing the computer to store a number of elements of the same data type in a specific order. Arrays are accessed using an integer to specify which element in the list to retrieve. Moving forward, we'll now translate the newly introduced abstract computer terms into the typical hardware components found on a personal computer. A personal computer typically contains the following: a CPU or processor, distinguished by the number of cores and the speed, such as quad-core 2.5 GHz. The RAM, or random access memory, expressed in size and speed, such as 4 GB and 1333 MHz. A long-term storage device, such as a hard disk drive, described by read-write speed and maximum storage capabilities, such as 1 TB 7200 RPMs. A GPU, or graphical processing unit, which is also expressed in size of onboard RAM and speed, such as 2 GB at 1046 MHz. Lastly, all of these hardware elements, typically modular, are assembled onto one board, called the motherboard, allowing for intercommunication between components. These elements are housed in a case and form the personal computer. With the fundamentals of computing behind us, we'll explore an introduction into navigating the operating system and working with file systems. This will give us the prerequisite knowledge needed to install, configure, and program with processing.